Reverse engineering of bicycle. In the automobile industry, reverse engineering is the process of collecting design data from automotive parts and reproducing it with modification. It can also be used to learn the process and subsequently improve the design. In the present work, CAD model of an old unused bicycle is created using the technique of reverse engineering and applying some conditions to the same model of bicycle to compare their behavior in different scenarios. The framework of this work is to learn and apply the concept of reverse engineering, CAD modeling, FEA, and to apply this to a bicycle and try to make it efficient. Introduction. There are broadly two types of engineering, one is forward engineering and the other one is reverse engineering. These involve the process of designing, manufacturing, assembling, and maintaining products and systems. Reverse engineering, RE, is a vital brand especially in the geometrical design and manufacture application area, and this technique has been widely recognized as a key step in the product development cycle. It is the process by which an artificial object is deconstructed to reveal its design, architecture, code, or to extract knowledge from the object. It is similar to scientific research, the only difference is the scientific research occurs for a natural phenomenon. It is applicable in fields of computer engineering, mechanical engineering, electronic engineering, chemical engineering. This study tries to examine the stress response and displacement of bicycle frames using models and then analyze solid structures. The material used in this study is steel AISI 1202. A structural analysis is an essential aspect for evaluating the strength and existence of the frame structure, which will be used for structural optimization. 2. Background. Finite element analysis or FEA is that the simulation of a natural phenomenon employing a numerical mathematic technique named as the finite element method, or FEM. This process is at the core of engineering, also as a range of other disciplines. It is also one among the key principles utilized in the development of simulation software. Engineers can use these FEM to scale back the quantity of physical prototypes and run virtual experiments to optimize their designs. This practical intention of the methodology meant that from the start, these methods were designed as quite just mathematical theory. These mathematical principles of FEA are useful in different sectors, like computational fluid dynamics or CFD. In this study we are focusing on structural analysis. To run a FEA simulation, first a mesh is generated. This is a way of transcribing a 3D object into a series of mathematical points that can then be analyzed. The density of the mesh can be changed based upon how complex or simple a simulation is needed. Calculations are run every single element or point of the mesh and so combined to form up the general outcome for the structure. Since the calculations are done on a mesh, instead of everything of an object, it means some interpolation must occur between the points. These approximations are usually within the bounds of what's needed. The points of the mesh where the info is understood mathematically are mentioned as nodal points and have a tendency to be grouped around boundaries or other areas of change in an object's design. 3. Methodology. This project has been divided into 7 modules. It is initiated with disassembling the bicycle followed by measurement of the parts. Later CAD model is created for the disassembled parts followed by assembling and FEA of model under different scenario. The detailed flow chart of the reverse engineering process is mentioned below. Disassembling of bicycle. 2. Taking measurement. The disassembled parts have been measured using vernier caliper and inch tape. The measurements were recorded and was used for creating the CAD model of bicycle. It had also been documented for further reference or studies. The finite element method has been used to measure the stresses and deflections of a bicycle frame caused by loads applied while cycling. In above comparison, more deflection is observed in standing pedaling, uphill riding and downhill riding respectively. This deflection is occurred due to higher stress of models in above conditions. Since the deflections are in we aren't able to see them with the naked eye. There may be other riding conditions which produce higher tube stresses than the cases considered here. In particular, the influence of dynamic loading due to rough and bumpy roads could be significant. When we compare yield strength and max stress obtained in bicycle model during FIA, we can say that the bicycle is in safe condition, but when we observe the breaking point in results, we can say that the material will start to fracture in these breaking points over a period of time. We can observe the respectively. These factory of safety of bicycle is 15, so the bicycle will experience failure at 15 times the design load. V. Conclusion. The bicycle has been disassembled and measured in a bicycle shop. These measured values have been used to create the CAD model of bicycle parts in Autodesk Inventor. The bicycle models have been assembled on the same software and the whole bicycle has been created. 4 loading conditions have been calculated in this project, i.e., normal pedaling, uphill riding, downhill riding and standing pedaling. This calculated value of loading has been imposed on bicycle model using stress analysis in Inventor software. When we examine the results and compare them to the yield strength, we can conclude that the bicycle is safe. However, in the long run, there may have been some fractures, as evidenced by the results. The FIA simulation results show there are still many opportunities for optimization of this bicycle model design, with the aim not only of reducing material used but also increasing the life of the bicycle. Optimization is required to reduce the amount of material used in bicycle models, but the importance is that the bicycle remains within a safe tolerance and provides comfort to users.